Imagine standing aboard one of the most advanced military fleets ever assembled. Around you, satellites sweep across Earth from orbit. Powerful radars search hundreds of kilometers in every direction. Infrared cameras detect tiny heat signatures. Electronic intelligence systems listen across the electromagnetic spectrum. Fighter pilots, trained to recognize almost anything that flies, patrol the skies. Never before has humanity possessed so many eyes and ears watching the same piece of sky. Yet what happens when all of these extraordinary technologies witness something they cannot confidently explain? Is the mystery really about what was flying there, or is it about the limits of our own understanding? Over the past 2 decades, a handful of military encounters involving what are now officially called unidentified anomalous phenomena, or UAPs, have become famous not because they prove extraterrestrial visitors, but because they challenge something far more fundamental. In several well-known cases, multiple independent sensors reportedly observed unusual objects at the same time. Radar tracked them, infrared systems recorded them, pilots described seeing them with their own eyes. Sometimes these observations appeared consistent, sometimes they did not. Instead of converging on a single explanation, the evidence often seemed to open even more questions. If our best sensors cannot always tell a coherent story, what exactly are they telling us? Many people immediately jump to the question, are they aliens? It is an exciting question, but perhaps it is also the wrong one. Throughout history, science has rarely advanced by correctly guessing the answer to a mystery. It advanced by discovering that the original question itself was incomplete. Centuries ago, people wondered whether lightning was supernatural. The breakthrough came when scientists asked what physical process produced lightning. People once insisted rocks could not fall from the sky because there were no rocks in the heavens. Only later did meteorites reshape our understanding of the solar system. Even pulsars were briefly nicknamed little green men because their radio signals appeared so perfectly regular that some scientists jokingly considered an artificial origin before discovering rapidly rotating neutron stars. Could today's UAP mysteries simply represent another chapter in humanity's long history of asking fascinating but incomplete questions? Perhaps the real puzzle is not whether extraordinary objects exist, but why extraordinarily sophisticated sensor systems sometimes produce observations that experts cannot fully reconcile. Modern military systems are masterpieces of engineering, yet each one measures only a small slice of reality. Radar measures reflected radio waves, infrared cameras detect heat, optical cameras capture visible light. Electronic support systems monitor electromagnetic emissions. Human observers contribute experience, judgment, and unfortunately their own limitations. When all of these pieces are combined, investigators expect the puzzle to become clearer. Yet in some cases, the opposite seems to happen. Why would more information sometimes create more uncertainty instead of less? Imagine investigators replaying every millisecond of an encounter. Engineers examine radar returns, physicists analyze infrared signatures, pilots compare eyewitness accounts. Intelligence analysts search for classified aircraft programs. Software specialists inspect algorithms for possible processing errors. Meteorologists reconstruct atmospheric conditions. Artificial intelligence searches millions of data points for hidden patterns invisible to humans. Every expert finds something useful, yet none can completely solve the puzzle. Is the mystery hiding in the sky, or is it hiding inside the way we combine and interpret enormous amounts of information? This raises an intriguing possibility. What if future generations create entirely new scientific disciplines, not to hunt extraterrestrials, but to understand why complex observations sometimes resist simple explanations? One possibility could be sensor intelligence, a field devoted to understanding how different sensors observe the same event, how uncertainty propagates through data, and how artificial intelligence can estimate confidence instead of simply producing answers. Instead of asking, "What is that object?" researchers may begin asking, "How certain are we that every sensor is observing the same physical phenomenon?" That subtle shift could transform investigations in aviation, astronomy, autonomous vehicles, national defense, and even medicine. Another emerging field might be called anomaly science. Rather than focusing on UFOs, it would study observations that survive careful attempts at conventional explanation. Such a discipline would investigate unusual radar returns, rare atmospheric plasmas, unexpected electromagnetic effects, optical illusions, AI recognition failures, sensor calibration limits, and events where multiple technologies disagree. Most anomalies would probably receive ordinary explanations. Some might reveal previously unknown natural phenomena. A few may remain unexplained for decades. Yet history suggests that even unsuccessful investigations often improve scientific understanding. Could studying anomalies become as valuable as studying ordinary events? Artificial intelligence may become the catalyst that changes everything. Today's analysts can only examine a tiny fraction of the enormous streams of data collected every day by satellites, aircraft, naval vessels, and ground stations. Future AI systems may compare billions of observations collected over decades, searching for relationships no human could ever notice. Perhaps some mysteries will disappear as hidden sensor errors are uncovered. Perhaps AI will identify subtle atmospheric effects never before recognized. Or perhaps entirely new categories of natural phenomena will emerge from patterns buried inside mountains of seemingly unrelated data. If AI begins revealing answers that humans never thought to ask, are we witnessing the birth of a new era of scientific discovery? This possibility extends far beyond military technology. Self-driving cars must combine cameras, radar, lidar, and GPS into one reliable picture of reality. Space telescopes merge observations across multiple wavelengths. Climate scientists integrate satellites with weather models. Medical imaging combines MRI, CT scans, ultrasound, and AI interpretation. In every one of these fields, the challenge is remarkably similar. Reality is not observed directly. It is reconstructed from imperfect measurements. Could the UAP debate simply be drawing attention to a challenge that exists throughout modern science? Perhaps the greatest contribution of these mysterious cases will not be proving extraordinary visitors or secret technologies. Their greatest contribution may be forcing humanity to rethink how evidence itself is interpreted. Science has never progressed by avoiding uncomfortable observations. It has progressed by confronting them with better instruments, better mathematics, and better questions. Every unexplained event becomes an invitation to improve our understanding of nature rather than defend our existing assumptions. So perhaps the question that future generations will remember is not, did aliens visit Earth? It may instead be, why did humanity's most advanced sensors sometimes fail to produce satisfying explanations? The answer may reveal nothing more exotic than new atmospheric physics, unexpected properties of electromagnetic waves, hidden limitations in artificial intelligence, or new principles of sensor fusion. Or it may reveal something none of us has yet imagined. Either way, the destination is the same. The greatest mystery may never have been what the sensors saw. The greatest mystery may be why our interpretation of reality still has so much room to evolve. And perhaps that, more than any speculation about visitors from the stars, is the beginning of the next scientific revolution.